21. We're going to identify and graph the polar equation r squared equals sine of 2 theta. Now this is a Lemniscate, and I will show you that form in just a moment. Right now let's test for symmetry since we have to graph it. So the first test we're going to do is see if it's symmetric to the polar axis by substituting in our theta with negative theta. So we're going to get sine of 2 times negative theta, which equals sine of negative 2 theta. Since sine is an odd function, this equals negative sine of 2 theta. Since these two equations are not equivalent, this test fails. So our graph is not going to be symmetric to the polar axis, i.e. the x-axis. So let's do the second test, and that's with symmetry with respect to the line theta equals pi divided by 2, which is the y-axis. And to do that, we're going to replace our theta with pi minus theta. So we're going to have r squared equals sine of 2 times pi minus theta. This equals sine of 2 pi minus 2 theta. Now let's use our difference formula for sine and go ahead and expand this as equals sine of 2 pi times cosine of 2 theta minus cosine of 2 pi times sine of 2 theta. All right. Doing this, we know this sine of 2 pi is 0. Cosine of 2 pi is going to be 1. So what we're going to get is r squared equals negative sine of 2 theta. So this test fails as well. It's not going to be symmetric to our line or our y-axis. Let's check the last test and see if it's symmetric to the pole. That's where we substitute negative r in for r. So we have this. And when you square a negative, you get positive. So this is the only test that passes. Our graph is symmetric to the pole. So that means we're going to go ahead and assign values of theta to from 0 to pi. All right. And this is what a Lemniscate looks like. Something like this. I think ours is going to look exactly like this one. So let's see what we get. Let's substitute in our values. Remember, if you we're trying to find r. So r is really plus or minus square root, let me erase this, of sine of 2 theta. Now when you substitute in 0, you're just going to get 0. Excuse me. If you substitute in pi divided by 6, you're going to get plus or minus square root of 3 divided by 2. And I already put that in the calculator to save time. And for pi divided by 3, you get the same thing. Plus or minus square root of 3 divided by 2. And then we're going to have this. At pi divided by 2, we get 0. At 2 pi divided by 3, it's undefined. Undefined. And at pi, we're at 0. So let's plot some of these points. The one I didn't add was pi over 4. So if I do pi divided by 4, and that's going to be sine of pi divided by 2, plus or minus. And that's going to equal, sine of pi over 2 is 1. So that's plus or minus 1. So what I'm going to look at is pi divided by 4. which is right here. And instead of going out 1, I'm going to let this be my 1. Just because this is so small. All right. So this is going to be 1. Now, at 0, we have 0. At pi divided by 6, we had close to 1. So that's going to be really close to 1. And it's also close to 1 here. All right. And then at pi over 2, you're coming back to, so it's looking like this. Now, since it's symmetric to the pole, we can also come out and look at quadrant 3. So at quadrant 3, at this is 5 pi divided by 4, we're going out 1, even though I'm really going out 2. I just want it to be bigger. And then just get really close here with your 7 pi divided by 6 and 4 pi divided by 3. So it's going to swing out here. And there it is. Thank you. Have a nice day. Bye-bye.